When I am decreasing the voltage, gap is decreasing and duty cycle is increasing. Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. This is our third video on TL494 to discuss about dead time and soft starts. What is dead time? When we say we are designing a push-pull or half-bridge circuit, in that time we use two MOSFETs, and when we use two MOSFETs for switching, this is transformer primary. Here we have positive voltage. For example, we have one switching device here and the second switching device here. We have one signal here, either it is MOSFET, IGBT, anything. In ideal case, we say it is generating square wave. So in case of square wave, the ideal signal when it is applied to the base, it goes high. The output must be similarly high. But no, in practical life there is a big difference between this theory and the practical circuits. So this is our push-pull drive. One signal is high, second is low. The first is low, second is high. When the second is low, first will high. These will work opposite to each other. Now if this MOSFET is turned on, it is causing to flow the current from here. When it is turned off, the second should turn on. So when we remove the signal, this MOSFET or this transistor will turn off immediately. But in practical life, if we say it should work like this in the output side, but practically when we apply signal to turn on, when we remove the signal, for example we remove signal from here, at that time it will take time, because here is a pressure of electrons, electronic current. So due to this pressure, this MOSFET or this junction cannot close its current immediately. Okay, I will make it more clear. For example, we applied signal here on the base. In that time, the ideal condition, the current must flow immediately. But no, the current takes a time to reach its maximum position. And when we remove the signal, ideally the current should turn off immediately, but no, it takes time. This is signal, this should be, and it is in practical life. So the time from its 10% to its 90%, it is called rise time, and it is called fall time. From 90% to its 10% value, it is called fall time, T-fall. So when the current is flowing from this side and same time, the collapsing magnetic field will make overstress here and also stress here. To protect both channels to conduct together at one time, we need a delay time between these signals. How it is possible? If this signal is off here, then in ideal condition we can say the second signal must start from the same place. To protect this crosstalk, a time between the switching of two channels is allocated to protect crosstalk between two channels. So it is called dead time. When the both MOSFETs are in off condition, when the both channels in off condition, that is called dead time. So this dead time, how we can obtain in this TL494? In our last session I discussed that if we connect pin number 4 to the ground, this IC will generate 3% dead time automatically. it will give 3% dead time for the both channels. When one channel is off, the second will turn on after a specific time, that is by default 3%. But we can increase this dead time by adding two resistors here. I shared the calculation formula in my last video. So we can connect two resistors between V reference pin number 14 and the ground, and we can divide. So its biasing current, that is -2 microampere to 10 microampere. We can calculate the resistors between V reference, and we can connect a voltage source here. The voltage from 0 volt to 0.4 volt will provide 3% dead time. If we will increase the voltage at this pin number 4, so it will create a more gap between two channels. So I connected a variable resistor 20k. We can use 100k. It should not be less than 5k. The sum of the two resistors, RS and this one, R1, R2 or RS, it must not less than 5 kilo. It should be above 5 kilo ohm. So if we will connect less than 5 kilo ohm, it will cause a overload on the reference pin, because the reference pin have a very limited current. Now I have just only 4 millivolt on the pin number 4, that is here. I connected this pin number 4, 1, 2, 3 and 4 number pin, that is 4 millivolt here. Now I will increase, and we can see the dead time between two channels. Now the gap is increasing between two channels. When the voltage are increasing at this pin, the dead time is increasing, because we are increasing the threshold. What we are doing, it is the ramp signal, 3 volt ramp signal at pin number 5, that is CT pin, that is here, 1, 2, 3, 4, 5, pin number 5. So this CT pin, if we will increase the voltage at pin number 4 above than 3 volt, above than this trigger, this ramp voltage, this sawtooth wave, the output signal will minimized. I am increasing voltage at 3 volt. We can see we are finding just only very minimum signals. At 3 volt or above, this pin will disable the function of this IC, and this IC TL494 will go in shutdown state. So now this IC is an off condition. When I am decreasing the voltage at this pin, we can see the gap between two channels is decreasing now. When I am decreasing the voltage, gap is decreasing and duty cycle is increasing. So by adjusting this 4 number pin, we can adjust the switching level of the IC. We can say we can make a variable power supply using this switching action by controlling the duty cycle. As this potentiometer is increasing its resistance, the voltage drop, voltage difference between these 2 points, because here must be 2 resistors, but I am using one potentiometer, and the slider of the potentiometer is connected to pin number 4. So the voltage drop, taped voltage between this center pin and the two terminals V reference and ground will apply to pin number 4. Similarly, here I have compensation pin. So it controls the duty cycle. It controls the duty cycle, but this function It controls the dead time between two channels. If we limit the dead time here, this is for protection. Now the duty cycle will just only work between this limit. So this IC will work in a narrow window. But if we decrease the potential at pin number 4 and then we adjust the feedback, this IC will work from minimum to maximum. So it will work in wide window. But if we increase the dead time, that time the IC switching time, turn on time will decrease automatically with respect to this resistor value. Now there is second subject, that is called soft start. What is soft start? We have this power supply. Here we have 12 volts. So this power supply, and here we apply signal on the base. If we turn on this IC directly, this capacitor is empty. When the capacitor is empty, it will cause to draw more current. It will generate a surge. When this circuit is dead, it is totally off, this capacitor is empty, and we turn on these MOSFETs immediately, it will cause to generate a surge on this MOSFET. It will cause to flow a full current. So to protect this MOSFET from full current, if we turn on at this cycle, it can damage the MOSFET, or it can damage the rear circuit, which is DC rail and bridge rectifier and other circuits. To protect from this damage, to protect from this surge, initial 25 to 100 cycles are used to switch this circuit linearly, slowly. It have to increase its duty cycle. Instead of switching at full rate, it will switch in this period. If our duty cycle is 5 microsecond, this duty cycle will limited to 2 microsecond for 25 to 100 cycles, so that it will switch slowly and this capacitor will maintain charge like this. When it will take full charge, full voltage, then the duty cycle will maintain at full rate, for example 5 microsecond. So this function in initial startup, that is called soft start circuit. To make this IC as a soft start, it is same dead time pin. A capacitor here at pin number 4 and V reference is connected. When it is off, the circuit is off, we turn on initially this, because empty capacitor works as a short circuit. When it will start charging through this resistor, so it will cause to increase the voltage across this capacitor, and this pin will drop. When this capacitor is working at short circuit, so 5 volt will cause to applied at pin number 4, so this pin will monitored as high. So pin number 4, when it is high, it will disable the function of this IC, and when it will start charging, the voltage at pin number 4 will start to decrease. So the ramps will start switching like this, and when threshold is here, so it will just only switch in this period. When the threshold at DTC, dead time control pin, will decrease from the dead time period, at that time it will adjust its full duty cycle. For example, this IC is switching at 60 kilohertz and we need 25 to 100 cycles. First of all, we know 60 kilohertz. To find the time period for one cycle, that is T is equal to 1 over F. T is equal to 1 over 60,000. 1 divided by 60,000, it is 1.66 10 raised to power 5. We can say 16 microseconds for one cycle. So time period 16.6 microseconds. So if we need 100 cycles, total time, soft start time 16.6 multiplied by 100, it will become 0.0016 seconds. 0.0016. Now we need the value of this capacitor. Soft start capacitor, time soft start divided by R soft start, this resistor, that is for dead time control. So we need 0.0016 second divided by 1K resistor. For example, we adjusted this 1 kilo ohm resistor for our dead time 5%. So we need capacitor value divided by 1000. It is 1.66 microfarad. So we need 1.66 microfarad capacitor to connect here. 1.66 microfarad capacitor will be connected between the V reference and pin number 4. I have this 1 microfarad capacitor. We will connect between dead time control pin and V reference. So this pin is V reference pin and this is pin number 4. Or we can connect directly to pin number 14 and pin number 4. So we can connect this capacitor between pin number 14 and 4. So pin number 14 is connected here to this potentiometer at this point and here. So we can connect this capacitor at these two pins. In the initial signals, it is switching slowly for the required period. When this circuit will reach at specific time, it started slowly. In the initial stage, this capacitor is causing to start this IC in slow mode. When the time will complete, which we calculated 0.0016 second, so after that time this IC will adjust its duty cycle at full rate. In startup, the soft start circuit now is causing to control the duty cycle. Then it will increase its duty cycle at specified full rate. In the next startup, it is working the same. So it is function of the soft start. So in this video we discussed soft start and dead time control. So here we can adjust the dead time. So dead time will limit the duty cycle within 0% to a specific level which we will adjust from here. But this feedback control will adjust duty cycle to its that limit which we have set from here. I hope so this video is informative. If it is informative, hit the like button. If you have any question, please let me know in the comment box. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.